Okay. I have no idea what just happened there. So, I'm going to show you guys how to do this type of problem where you're given your actual yield or your percent yield, and you have to go figure out how much there is of something, okay? You've done this several times in your packet, as well as in the review guide that I gave you, so it's kind of a pattern you just have to follow whenever you see this type of problem. So first thing you need to do is figure out what we've been given here, okay? So we know that our percent yield is 85%. We know that they eventually want us to get us to liters of chlorine. And look, we have a given. 112 grams of NaCl. Okay? So whenever I'm given a percent first, chances are I'm going to need to use that percent in my percent yield equation before I go do stoic. So a lot of mistakes I've been seeing is that people have been doing stoic first and then plugging into the percent yield, but it's actually the opposite. So we know that we're going to make 85% of what we plan on making. Our goal, it says it right here, we need to produce 112 grams of NaCl. So whenever you're given a given like this that says, hey, we want to produce this, that's going to be your actual. Okay, and if you look over here, the actual value goes on top for your percent yield, and the theoretical yield goes on the bottom, and you multiply it by 100%. So the theoretical yield is how much you should make in a perfect world where everything is used perfectly. That's usually not the case. Usually there's some sort of error, whether you missed something in your sample or you washed something off too much or whatever. So basically what this is saying is, hey, we need to figure out how many ingredients we need to have to shoot for to be able to know that we're going to end up with 112. So basically we need to overestimate for ourselves, knowing that we have some error here. Okay, a perfect yield would be 100%. We obviously don't have that here. We have a little bit of error. So what we first need to do is figure out our theoretical yield. Okay, that would be this bottom guy. And the way we usually find theoretical is by doing a stoic problem. Okay, so you're going to go ahead and solve for x. So I'm going to divide both sides by 100 so that I can start isolating variables. So I have 0.85. Okay, now I'm rid of that 100. And that's going to be 112 grams of NaCl divided by x, which is my theoretical. It's how much I should shoot for. In order to get x alone, I need to multiply both sides by x. Cancel that out. This becomes 0.85x is equal to 112 grams of NaCl. You should know by now in math that you divide by whoever your lone variable is with, and then we get x equals 112 grams of NaCl divided by that 0.85. So I'm going to do this on my calculator. I'm sorry I don't have it on video. You should get this number. Okay, so this is our theoretical yield, and what this is saying is, hey, if I put enough ingredients to hopefully make 131.8 grams of NaCl, if I know that I have an 85% yield, if I'm only going to make 85% of that, that's going to end up being 112 grams that we're going to end up actually making. So 112 is 85% of that theoretical yield. Okay, so that's your first step. You're going to go ahead, find theoretical. Theoretical is your x. The number they gave you is going to be your actual, and then your yield is obviously that yield. You're solving for x to see, hey, how much should we be shooting for, knowing that we have error. Now that we have this theoretical yield, okay, if you go back and read the question, it is asking you to see how much chlorine we need to be able to make that much NaCl, okay? So what we're going to do is we're going to say, hey, if I'm shooting to make 131.8 grams of NaCl, I can do a 4-step stoic problem to be able to figure out how many liters of chlorine that would take for that goal. So I know that I'm ending with liters of chlorine. I know that liters has a 22.4 next to it. I know that I started with 131.8 grams of NaCl. That's my theoretical. I'm going to go directly diagonal and put grams of NaCl. Okay. If I go to the periodic table, I know that Na plus Cl is going to be 58.44 grams. I know that that's the molar mass, which means that that number is equal to 1 mole of NaCl. I'm going to go directly diagonal because I said so. Okay. I need to now convert to moles of Cl2. And again, go diagonal. Over here in this fraction, I know that there are 22.4 liters in every 1 mole. And then seeing this mole ratio right here, oh hey, this wasn't balanced. Okay, I know that there is 1 chlorine for every 2 NaCls. And now I'm able to solve this stoichiometric problem. So I'm going to say 131.8 times 22.4. I'm going to divide it by that 2, and then divide it by that molar mass of 58.44. I end up getting the number 25.3 liters of chlorine. What this is saying, this is our final answer. Look, it's the unit we wanted to be in. This is saying, hey, if I use 25.3 liters of chlorine in a reaction, it's going to end up making NaCl. And because I know that my lab equipment isn't that good, or I'm not that good at labs or whatever, I know I'm only going to make 85% of what I should make with all of that chlorine. So then that will end up equaling the 112 grams because we were planning for more than that to be able to get to the 112 grams there. Hopefully that helps you. I'm going to be honest, like here's a testing strategy. It's not a good learning strategy, but a good testing strategy. I would just start like memorizing the processes. That if I see a percent and a given, I follow this process of plugging X in for theoretical, then putting my answer for theoretical into a 4-step stoichiometric problem. Hopefully that helps you guys.